Hello students, again I have come up with another video of logarithmic differentiation in coordination with the earlier video, which was just an introduction and a necessity concept introduced why logarithmic differentiation is important or necessary or helpful for how it is helpful for us. Just repeating few lines of the last video. Last part I have explained that whenever there is function to the power constant to the power function and constant to the power constant, derivatives are available, and I have also told the derivatives. What are the derivatives of this? Derivative of this x to the power a is a x to the power a minus 1. Derivative of this is a raised to x natural logarithm of a. Derivative of a raised to a, that is constant, so its derivative is 0. Only combination which is left out is x raised to x. So in this case we apply logarithm. Suppose it is equal to y, then if we apply log x to the power x is equal to log y, then this x can be brought down. So it is using laws of logarithm. Log x is equal to log y, and now we are in a position to differentiate. If we differentiate this equation, x log x is equal to log y, we will be actually finding the derivative of y with respect to x. So differentiating with respect to x, we get what? There's a product rule can be seen very clearly. We have to apply product rule. First function derivative of second plus second function derivative of first. Derivative of x is 1 is equal to log y, derivative is 1 upon y dy by dx. So it is 1 plus log x, which is equal to 1 upon y. So this y can be transferred here. So you get dy by dx. So therefore dy by dx means ddx of x की power x is equal to y को पहले लिख दो x raised to x, and this is 1 plus log x. So this is how we have found out the derivative of x to the power x. Okay, derivative. This is another formula. You can add up to the list of formulae. Okay. Now we have another example. With the help of another example, we can find it out, the derivative of the logarithmic functions. We'll take another example, little complicated ones, which is really tough to be understood. Not so complicated. In the beginning, we'll have to take a little bit easier ones. Suppose y is equal to sin x raised to cos x. So it is function to the power function. In this case, we have to apply log. So solve it. How will you solve? We will take one variable. This y has been taken. So we will apply log. Applying log on both sides. Log y is equal to log of sin f x to the power cos x. This implies log y. This cos x will come here and sit besides log sin x. Cos x dot log sin x. So now differentiating with respect to x, we get derivative of log y is 1 upon y dy by dx. It is equal to first function cos x into derivative of log sin x. Again, chain rule we have to apply. So what is derivative of log sin x? It is derivative of log sin x. Derivative of sin x. Derivative of log x is 1 upon x. So 1 upon sin x into derivative of sin x, that is cos x, plus second function, that is log sin x into derivative of cos x, that is equal to minus sin x. So if you want to jot it down in a proper way, then we can write it like this. We can do it like this. Sin x can be brought it down common. Here sin x, we can multiply it here, and this minus sin x can be written first. So this is what cos square x minus sin square x into log sin x. This is your final answer. No, it is not final answer, sorry, it is not final answer. Still this y we have to transfer. So dy by dx, when this y will be transferred over here, I'll have to write what? I'll have to write y times, and then y can be resubstituted, because y we have in y, if it is given in the question, you write it simply y only. But if it is not, it is written like this. If it is only given sin x to the power cos x, and we are taking variable y, then we have to replace this y. In this case, in the question, if it is given, you leave the answer in terms of y like this and implicit differentiation like this. So I hope you understood this. We will take a few more examples. In the next video, I'll come up with more examples which will clear your doubts, and you can easily become expert. Okay.